Hey, what's going on, guys? Let's try these problems right here. The first question is asking a very long wire carries a uniform linear charge density of 7.1 nanocoulomb per meter. What is the electric field strength 18.5 meter from the center of the wire at a point on the wire's perpendicular bisector? And they're asking to provide this one into Newton per coulomb. Now let's see how we can find it. First of all, for example, here we have electric field at a distance r, right? So we are trying to find at this distance. So we have to use the equation that is related to the distance. That's E is equal to. Also we have linear density. So we have to put an equation that's related to linear density and the distance. So that equation is going to be E is equal to 2k lambda over r. Here k is Coulomb's constant, lambda is linear charge density, and r is the distance. So we have everything available, right? Linear charge density is here, distance is here, and all we have to do is just plug the values. Now this one, instead of this one, Coulomb's constant, you can use 9 times 10 to the power of 9. So 2 times 9 times 10 to the power of 9 times linear charge density is 7.1 nanocoulomb. Nano is 10 to the power of minus 9. And in the bottom we are going to have the distance, that is 18.5 meter. And this is a good thing, we have negative power negative 9 and positive 9 that cancel each other. And if you calculate this one, you should get 6.91 Newton per coulomb, right? Now let's look at the second question. The second question is asking an electric dipole consists of charges plus and minus 4.3 microcoulomb separated by 1.8 millimeter. It is placed in an electric field of magnitude 549 Newton per coulomb oriented such that the dipole moment makes an angle of 140 degree with the electric field's direction. The magnitude of the net torque this field exert on the dipole is what? So they are asking to find the torque on this field. Magnitude of the net torque this field exert on the dipole. So we are trying to find the torque, and this is a electric dipole. Now when we have dipole and if they ask for the torque, we can use this equation. Torque is equal to EQD sine theta, right? EQD sine theta. Here E is electric field, Q is charge, D is the separation, that is 1.8 millimeter, and sine theta, theta is this angle right here. Now all we have to do is just plug the values. Let's go ahead and do that. E is 549 and Q is, since we are trying to find the magnitude, we don't have to worry about the sign, we just multiply by the charge. So here 549 times 4.3 times 10 to the power of minus 6, and distance is separated by 1.8 millimeter, so this is going to be 1.8 times 10 to the power of minus 3 meter, and then sine theta, sine 140 degree. And if you calculate this one, you should get 2.73 times 10 to the power of minus 6, 10 to the power of minus 6 Newton meter, and that's going to be the final answer. I hope this helps. Thanks for watching.